Hello, everyone. If you're in the room and can point your the camera of your phone at the QR code, that'll help us have you registered as participants to the meeting. I have up on the screen right now. Oopsie. I'm trying to remember. Does anyone know how to get the clicker set up for the flash drive that doesn't necessarily go into the... Just trying to advance the slides, not working. Does anyone know how to advance the slides without the clicker? Yep.
Oh, you should choose to present them, and then presentation view,
Here's the present.
and then I think you choose,
Voila.
and then down here.
Yeah, I did this before. Sorry. Thank you. Stephen to the rescue. Okay. Sorry for being a goof. I haven't had enough coffee. Okay. All right. We're on. Thank you, everyone, for being here today. I'm getting an echo. So hang on. Thank you, everyone, for being here today. You're here for the Global Access to the Internet for All working group of the IRTF. As per the rules of the IETF and the IRTF, I'm showing you the Note Well slide, and it's an important reminder from the IETF of the policies that are in effect on various topics, such as patents or code of conduct. It's only meant to point you in the right direction. Exceptions may apply. The IETF's patent policy and the definition of an IETF contribution and participation are set forth in BCP 79. Please read it carefully. As a reminder, by participating in the IETF, you agree to follow IETF processes and policies. And note that people have laughed at me before for reading this out loud, but I think it's important to read it out loud because there's been some discussion in the IETF about the importance of people, you know, paying attention to the note well. If you are aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. I don't think that's relevant here, but just it's important you all know that, particularly if today is your first day participating. As a participant in or attendee to any IETF activity, you acknowledge that written, audio, video, and photographic records of meetings may be made public. Personal information that you provide to the IETF will be handled in accordance with the IETF privacy statement. Read it if you haven't. As a participant or attendee, you agree to work respectfully with other participants. Please contact the Ombuds team. The link is there if you have questions or concerns about this. Other definitive information listed below in the BCPs that you can see there and the other link to the privacy policy. Anyone have any questions about the note well? All right, thank you very much for your attention to that. Next up, our agenda. Very exciting. The Quick Bash here, and Curtis, I should say Curtis Heimerl and I are both co-chairs of Gaia. Curtis, could you say hello to everyone?
Yeah, hey everyone. Thank you so much for attending, and thank you particularly to Jane for handling this. I was supposed to be there. Family got mono, so I am in my basement, remote, even though this is the closest IETF to me for a year. So I'm very bummed, but thank you for handling it.
And if, for those of you that don't know Curtis, he's a professor in Seattle at Washington University, does great work, knows a lot about the topics we're covering here today. Wishing you well, Curtis, and the family. I hope you all feel better. We have a great agenda for you today. Naveed Haq, who's here, and I'll edit the agenda as we go, will speak last. Um, we'll have Innocent Obi up first, and he's going to speak to you from his presentation on La Terre est ronde, some challenges and contradictions in the quest for content locality in Africa. Jihong Luo will go after Innocent. Jihong is with us here today. Thank you for coming in person. And his presentation will be on democratizing cellular access with Cellbricks. After Jihong, Bharath Raghavan will be up. His presentation's on computing within limits. All the presentations have been uploaded. And Naveed will go last. That's partly because he's in Dubai, and it's better that he go last from his time zone. This presentation is about a new network the Internet Society's been working on with a group in the mountains of Nepal, Everest Community Network, improving internet connectivity for the Sherpas of Nepal. Each presenter will have 20 minutes to speak with 5 minutes for Q&A. I'm not going to give a presentation later, so we may have some extra time for good conversation. So Innocent, we're going to click over to you, and I'm going to pull up your slides.
Do I need to do anything on my end?
No, it's all on me. Hang on. There you go. Onward.
Awesome. All right. And do I just tell you next, or do I have more control?
Yep, I can handle that. Hang tight. Go for it.
Awesome. Hi, everyone. My name is Innocent Obi. I'm a third year PhD student at the University of Washington, Paul G. Allen School of Computer Science and Engineering. And I'll be speaking to you today. Let me start my timer so I don't go over. Sorry. I'll be speaking to you today about some ongoing research that we're doing at the ICTD lab. Um, um, Full acknowledgement, I am advised by Curtis Hyrule, who's also one of the chairs of this committee, and grateful for the opportunity to present some of our thoughts and research on this topic. And so the title of my talk is La Terre Ronde, Some Challenges and Contradictions in the Quest for Content Locality. A brief aside, there is a song by a French rapper, Orelsan, that goes by the same title, La Terre Ronde, and there's a statement in it where he says essentially the translation fundamentally, the world is round. Au fond, je crois que la Terre est ronde pour une seule bonne raison, for one good reason, après avoir fait tour du monde, tout ce qu'on veut c'est être la maison. So after one goes around the world, all one wants is to come back home, and that was essentially kind of the emphasis of, or the thesis of the idea behind this talk, is this kind of circularity of traffic, irrespective of kind of the location it begins in. For traffic to travel from A to B, it kind of has to go the entire world, only to come back to where it started. So next slide. So this is essentially the content locality problem. And so this is from a great paper written 2018, Nation State Hegemony and Internet Routing. And I'll kind of read it at length. For example, over 50% of the top domains in Brazil and India are hosted in the United States. About half of Kenyan paths to the top domains traverse the United States and Great Britain. Much of this phenomenon is due to trambooning, where an internet path starts and ends in the same country, yet transits an intermediate country. Infrastructure alone is not enough. ISPs and respective regions need better incentives to interconnect to one another to ensure that this traffic stays local. Next slide. And so this is kind of a visualization of the core idea taken from a blog that Cloudflare wrote a couple years ago. Essentially, if a user wants to visit content, odds are that request will leave the content or their region, travel somewhere else, and then be kind of bounce back to that user. And so this adds costs, this adds latency, implications. This has implications in just traffic in general. And this is generically considered in the internet space trambooning. And the goal of keeping content local is to stop the trambooning of traffic and to keep traffic as local or as regional as we can, keep it traveling in paths that are regional rather than unnecessarily traveling through international links. Next slide. So the main idea here is that trambooning is a significant issue in the majority of the world. And we see this happening in Latin America, we see this happening in Africa, we see it's happening in countries and regions where there isn't sufficient or robust infrastructure, and a host of different economic actors have taken their own cuts of how they want to build and roll out infrastructure. Next slide. And so ISPs kind of there's this promise of peering as creating a flat internet. So the goal one way to solve this content problem is to create a physical location through which internet infrastructure companies like ISPs and CDNs can connect to each other. And these are called IXPs. And over the years, there's been a significant amount of work in boosting the IXP ecosystem on the continent. And so this graphic is taken from a report from ISOC called Anchoring an African Internet Ecosystem, Lessons from Kenya and Nigeria's Internet Exchange Point Growth. And they kind of lay out 3 stages of IXP development, ways of keeping traffic local, bringing international content in, and then kind of building and strengthening the local ecosystem for content delivery and provision. And the idea behind IXPs is that rather than using transit, which are kind of bilateral interconnection where a customer pays a provider for connectivity to the global internet, peering is kind of an arrangement between 2 networks where they bypass that transit provider, reducing their costs on transit and exchange traffic directly. And these happen obviously at IXPs. And peering obviously involves a number of traffic independent costs. These are fees, maintenance expenses, and et cetera. And then have traffic dependent costs, which are kind of larger ports for higher traffic rates, which tend to be more expensive depending on the IXP. And so for a majority of networks, peering tends to be the better option. Research has shown that particularly in Africa, a lot of local ISPs don't necessarily see the benefits of peering, but the big move in Africa has been to support and to encourage IXP growth, to encourage a flatter internet where there aren't too many intermediaries between links. Next slide. And so internet flattening refers to kind of reduction again in the number of intermediary organizations on the internet's path. And so the idea is that with more peering, we get a flatter internet. And this has been the kind of folk theorem of IXP growth and IXP development and IXP expansion. Next slide. But you might be, well, someone might ask, wait, but is this the correct measure of flattening? It's got a strong layer 3 smell. And everyone else responds, well, don't really worry about it. We don't have to worry about it. Links are physical and local, so there's nothing to worry about. Layer 3 smells aren't that bad. Next slide. So in general, IXPs kind of provide these three things, right, to different stakeholders. CDNs might want to lower costs and encourage direct and settlement-free traffic exchange, so they decide to peer an IXP. ISPs with lots of eyeballs want to connect directly to other large ISPs to reduce transit costs, so they might want to also peer an ISP. And transit networks may want to use the ISP as a way to sell services to clients, and so they might want to use the ISP. So everyone's got a reason to support the growth of a flatter internet, or the flattening of the internet, and support more IXP growth. Next slide. And so what we see in the data over the years is there's been a significant number of IXPs found in Africa since the mid 90s. And particularly in between 2011, 2015, and then on into 2020 today, we see kind of a large growth of new IXPs that are being founded on the continent. Next slide. And particularly if we look at the kind of the IXPs, if we look at the number of connected networks per existing IXPs, we can see at the very, very end that I've circled, I don't know if you can read it, but NAP Africa, it's an IXP, has the largest number of connected networks. Now, I only highlight this because it's important for the general story I'm about to tell. But in general, IXPs promote, makes it cheaper to interconnect more networks, and obviously has the benefits that I described above. So next slide. So the takeaway is peering in IXPs can keep traffic local, and we know this, and it keeps the internet flatter. Next slide. All right, so now that we have peering in IXPs, and we know that it's going to keep the internet flatter, we can also add caches and POPs at these IXPs. And that can definitely keep international transit local. And this is kind of screenshots taken from an AIGF, an IGF forum a couple years back, where some representative from Google was explaining how they choose where to peer, and then where to put POPs and where to put caches. And it's slightly convoluted, but there are a couple of different reasons, and no one really knows. It's a fairly complicated decision for a content provider to decide whether or not they want to put a cache or a POP. Next slide. And so an IXP goes to a content provider and asks, can we get a cache? And the content provider does some kind of calculation. Next slide. And usually the answer they get back, usually from Google, is no. Next slide. And so there have been initiatives like the Open CDN concept, run by a couple of Brazilian IXPs, as a way to kind of fix or circumvent this issue. And Open CDN is a shared infrastructure initiative, and it helps CDNs reach Brazilian internet users with low delay. And essentially is a way of grabbing smaller ISPs to make it look like there are larger eyeballs in a particular network. And this can then attract a CDN to an IX versus each individual ISP going to the CDN and asking for a cache. Next slide. But as we know, cache fill is too damn high, right? And from what I've heard in the kind of Whisper network, no one's necessarily no one's found a fix to high cache fill. And this is a kind of an RFP put out from the Internet Society a couple of years back, trying to find kind of ways of covering cache fill for ISPs connected at an IX. Next slide. And so there are a couple of things here, question marks. One being that more CDNs are actually going into creating their own offnets and kind of leaving IXs and going deeper into going closer to the customers into ISP networks. And there have been recent proposals to share cache infrastructure like the Open CDN work. However, when these caches are behind kind of a peer's network, there's what we call an instability that we believe requires incentive alignment, and we call these cache games. And so in our work, we kind of identified two types of cache games. Next slide. So the first is the inter-ISP cache sharing game. This is when you have a number of ISPs connected at an IX, and one ISP has a Google Global Cache, and they might decide to advertise the routes to this cache to the other ISPs on that IX fabric. And this can work to a certain extent if the ISP doesn't have significant limitations or concerns about saturation of that link. Maybe they don't have a lot of eyeballs on their network. They might not worry about the trade-offs in letting other ISPs use those routes. But when, for example, if ISP4 gains 200 new customers and all of a sudden that link becomes really important and that trade-off becomes a little bit more expensive, then it's potentially the case where they could cut off access to that cache to other ISPs, or could negotiate pretty outrageous prices for all the other ISPs to use those routes. And so there's kind of an instability here when it comes to cooperatively cache sharing in this setup. Next slide. The other that we've seen in the wild is inter-IX cache sharing, where you have a number of IXs, or cooperative community IXs, that interconnect somehow on another IX LAN. And some of them might have Google Global Caches, and they're each independently finding out ways or figuring out ways to support cache fill. And so the idea here is it possible to only have one IX pay for that cache fill, and then have the other IX update their cache through that other IX that paid for the cache fill? And so we've seen in the wild instances in which IXs have made kind of handshake agreements where they've shared each other's cache updates and use one global cache to update the other global cache. But even here too, there's still an incentive alignment problem, right? These are usually just friendship agreements and friendly agreements. And so when those trade-offs become more costly, it's unsure what happens. Next slide. So the takeaway here is coordination and cooperation is still difficult even in the presence of IXPs, and the content problem is also deeply relational. And a lot of the work that happens now to circumvent these problems can't be repeated at scale. Next slide. So beyond just the cache sharing problem, there's the reality of peering and peering arrangements. And so in reality, what we see and what's been a practice, and we didn't realize this until talking to a lot of IXs, is that remote peering, which is a different peering behavior. There's direct peering in which there's the expectation that the other peer is physically located at the same facility, connected to that interface. But what we see more so now is a lot of remote peering in which that peer is not necessarily in the same facility, either uses some layer 2 provider to access the IX, or uses a reseller that has facilities, that has physical presence in that facility to then connect to that IX. And so what may appear to BGP as being a peer that's one hop away can actually be multiple hops away. And this has been something that's been in practice for years in the IXP, the peering space. Is a very contentious network engineering approach, but it's very, very common. And we believe it's one of the main things that's been driving IXP growth, particularly IXP growth on the continent. Next slide. And so this is a paper that was looking at the latency impacts of remote peering. And the only African IXP that they have on this list is NAP Africa, the one I pointed out to earlier, that had the largest number of connections. And the thing to highlight in this graph is they were comparing latency between remote peering and between a transit provider. And by and large, and the number is fairly significant for NAP Africa, where 98.1% of the remote routes had lower latency than transit. And so this is huge, obviously, because one, transit may be expensive, so you might choose to use an IX. But your traffic is also has better latency if you choose to use a remote peer. And that remote peer might not be one hop away in reality, might be multiple hops away, but has lower latency. And so the idea behind content locality, keeping traffic local, might happen at the cost of, or there might be a trade-off between keeping traffic local and using a remote peer. And so locality then ends up becoming more of an emphasis on cost and reduction in latency versus actually having the content physically present and local in the continent. The paper also goes and looks at the difference between local and remote and local and transit links. They don't do that for African IXPs because there's just a significant lack of data to do some of those comparisons. But this comparison enough between remote and transit is pretty stark. Next slide. And so these are just a couple of screenshots of evidence of not having used this strategy for a long time. And so again, we think significant amount of the growth in IXP or some of the reasons why networks choose to use IXPs is because of remote peering. Next slide. Also taken from the report on, another report on moving towards an interconnected Africa, we can see that the cost, the annual cost for NAP Africa. And so again, there's huge benefits to using remote peering, but the question is like, what impact does this have on actual content locality? Next slide. So there are a couple of things to think of. One is to BGP all paths are local. So there's not really anything we can do in BGP to distinguish between a direct peer or a remote peer. And even then, there's a lot that we don't know. And one of the main things is we don't know necessarily the latency differences between a peer that was connected directly and access to content through a remote peer. And we just don't have the data. There isn't research on that data. That's one thing that our lab is working on to try to understand what are the latency differences between local and remote peering. So what does this mean? Next slide. Next slide again.
And Innocent, just a heads up that you've got 3 minutes.
3 minutes. All right, great. More than I thought. Great. So what does this mean? It means that, well, we need better vantage points. A lot of the reports that have done research, particularly the one I pointed out, is just a lack of vantage points in Africa to do some of these measurements. And given what we've said, we need these vantage points also need to give us information on peering arrangements, because those are important, because we might infer something incorrect, because we might presume that a peer is connected locally, rather the peer might be thousands and thousands of miles away. And we don't know what this means for the level of content traffic happening in local CDNs and global CDNs. And then it forces us to refine what we mean by keeping content local. Is latency and cost enough? Or is there something, should we separate the need for supporting local content created locally in Africa and making that content available and accessible on the continent versus the ideas behind keeping our traffic local? Next slide. So the takeaway here is that we just can't fix what we can't measure. Next slide. And so to end things off, there's a really great book with my second analogy, Flatland, A Romance of Many Dimensions. And the book essentially just kind of talks through the problem of perspective. And a point can only see a point, a line can only see a line and points. A sphere can see squares and everything underneath, but nothing higher. Next slide. And so the idea here is our problem is that for a lot of our research that we've been carrying out has been a view from flatland. Links that have been dynamic, remote, not necessarily physically local, we've viewed and we've interpreted as being direct local connections. And so what does it do when we take a view from sphere land, when we take it to some of the rich dynamics of what's happening in the content? And I think on the continent, and I think it's important to consider this as we're going through some of this work. Next slide. So I'll end with this final quote taken from Flatland. Without the power of rising above or sinking below it, very much like shadows, only hard and with luminous edges, and you will then have a pretty correct notion of my country and countrymen. And so if we really want to fix the internet problem, the traffic, the content locality problem in Africa, we need better test beds, we need better vantage points, but we also need to know what we're measuring and what's going on. And there's very few work out there shining a light on what's actually going on in peering and connectivity on the continent as it regards to peering links and their impacts on latency. So thank you for listening. Next slide. And thoughts.
Anyone have any questions for Innocent? You can raise your hand in the queue so that we've got you logged in, and or step up to the microphone.
And there were a few in chat, so I'm gonna say those if people don't step up.
We
to the
do
queue.
have someone headed to the microphone. If you could just please say who you are when you speak.
Yes, I'm Matt Mathis. Until recently affiliated with Google and Measurement Lab, and I see a huge amount of opportunity here. I have a question about one of the things you didn't mention is the effect of the business plans of threatened incumbents. Because what we see in our data in most of the Southern Hemisphere is that the incumbents have the vast majority of eyeballs. And it surprised me that you didn't mention that.
Yeah, there's a lot I would love to mention. There's one slide I added in. Steve Song recently just did a global CDN map. He's kind of mapping out all of the different infrastructure bits on the continent. And so it raises the other point, which is in that Google slide that I put up, I didn't have enough time to go through a lot of the decks. So one of it is the calculations that they do on whether or not to bring a cache in is who are the incumbents, how many eyeballs do they have, how much power and control. Does it make sense to both put a cache in the incumbent and a cache in smaller operators? But the business model, I think, plays a huge role. We don't have answers. We just have questions, and we think that's one of the dimensions that influences how these topologies, these actual topologies in terms of remote peers exist. And we start to look at the big IXs like Lynx and D6 and even NAP Africa. I think a lot of that is a function of their market power. And then the smaller ISPs just kind of have to play along with that. And so there's a lot in this that we can't really unfurl, but I think having infrastructure that we can use to measure and understand this versus using peering DB, which has very limited information that we can use to understand the dynamic nature of these things. But I agree. I think that is a dimension, but I'm a junior researcher. But I think any insight that you have into things that might influence how we look at this will be super helpful. But yeah, thanks for the question.
Okay, and thank you for that, Innocent. We've got 3 folks in the queue, and then we had 2 questions in the chat. So if we can keep the questions short, answer short, we can get everybody in here, and we can even take a little bit of time because there are only 4 presentations. So Rajiv, you're up next in the queue.
Rajiv here from Piconets here in India. I just wanted to say that you might find it interesting to also expand the scope of some of the research data that you're collecting to also include India, because we are also going through a significant amount of churn in terms of connectivity with policy decisions from the government, for example, mandating as part of the ISP license the need to interconnect at IXPs. It's now reaching a point where the government says if you want to be an ISP, you are required, no longer recommended, but you are required to interconnect at IXP locations. And they're actually building out over 20 IXP locations under the public national internet exchange of India, NIXI infrastructure. And I totally get the point that other people also made, that some of the incumbents are just pretty much showing the middle finger to this requirement by saying one of the largest mobile networks in the country peers at the NIXI peering point on a 1 Gbps port. And this is a mobile operator with over 200 million subscribers. Right. So yes, we comply with the law, but that's about all you're going to get. If you really want to reach our eyeballs, come talk to us directly so we can bill you.
Rajiv, we're going to have you on the next Gaia. So, think about presenting. Do you have a question for Innocent, or it was really great data? We appreciate it.
And I'm just hopeful that he gets a chance to pull in some of the Indian data into his research.
It's a great
Yeah,
idea.
feel free to reach out to me afterwards. I can exchange my info in the chat. But yeah, I think now we have enough to deal with and just looking in Africa. But yeah, we'll definitely be interesting to see parallels when we expand that scope.
We're also doing some stuff in Africa. Happy to talk offline. Thanks.
Great.
Thank you, Rajiv. Mallory is up in the queue.
Hi, everybody. Mallory Noodle, Center for Democracy and Technology. I thank you, Rajiv, for bringing this up because I didn't know if it would be sort of out of scope for the discussion, but I think we are seeing a lot of laws like that in India where traffic localization is being mandated. And typically from a sort of net neutrality or sort of open internet perspective, those can be rather troubling. They're often done because local governments want jurisdictional control over data, either maybe censorship or other things. So, but I do think that there is then this benefit where you get a flatter internet. So I'm sort of compelled by, you know, maybe there's a side benefit here, but maybe it would be more useful to think proactively about how to incentivize then local traffic. It sort of goes to what I think Nick's come on the queue to talk about, which is, you know, why aren't bigger content providers localizing their traffic more? What are the barriers to that? And how do you incentivize that happening? Because it's more sustainable, it's, you know, more efficient. There's a lot of benefits to it, and yet it's still not happening. So short of mandating these things, which again can be harmful and can be motivated by nefarious reasons, you know, and this is maybe too high level for the talk. I just want to appreciate you measuring this and presenting this, because I think it shows that if we had a more proactive incentivizing frame for this, we could actually achieve a lot of benefits rather than having to think of these things as risks to the sort of landscape or fabric of the way the internet's structured. Thanks.
Thank you. That would also point to countries having better competition policy parameters too. Francois Nguyen, I hope I haven't massacred your name.
No, that's good. Francois
Okay.
Nguyen.
Bravo.
I'm wondering what's the incentive for people like Google, Facebook, Netflix to install caches? Who pays for it? Is there enough revenue from advertisements that they are willing to install infrastructure?
Innocent?
Yeah, so usually in most cases, it would be the network themselves that has to figure out how to cover that cache flow. And so Google usually wouldn't go in and say, hey, we're going to give you a cache for free. There are some cases, depending on if there's a significant amount of traffic at that IX, where Google will then pay for that. But usually the case is the ISP will have to figure out how to cover the cache flow.
And second question was, are there any cases where technologies like network optimization, like Riverbed Steelhead, are used? But I mean, because everything is encrypted, you would need to use a proxy or something, but that would compress everything, basically.
Yeah, so I mean, that's a bit out of scope of this presentation, but there's some work that we're thinking of in terms of a distributed CDN that's kind of locally operated. I think that would fall into that, and so we can talk offline. But yeah, I think just to get some of the questions through, it might be out of scope. But yeah, if you have more specific questions, feel free to send me a direct message.
Okay, thank you.
And we'll have to close the queue after Nick, if we don't mind. And maybe Curtis, Innocent, you and Curtis can coordinate to answer some of the questions that were asked in the chat. So Nick, we're gonna over to you.
Nick, yeah, just to continue that set of questions, just for a beginner, what are the like what's the biggest barrier to that large content provider providing a local cache? Is it Is it just the lack of the amount of traffic, or is there some what would you say is the largest disincentive?
At a first level, it would be the amount of traffic, because usually they'll come in and they'll commit to a certain port size. And so it's whether or not the traffic that they're seeing on those ports, or because they're looking at cache efficiency. And so if they're going to spend like infrastructure time to build out and to maintain this cache, we want to make sure that it's being used effectively. And if the cache isn't being used at all, there's no incentive for us to come there. And one way to increase cache efficiency is to have a significant number of eyeballs on that network. And so actually, Steve Song, like I mentioned earlier, just come up with this infrastructure map. And if you see it, you see like Facebook probably has the most amount in terms of edge infrastructure for their content on the continent. And the majority of this is because it's easy to optimize for efficiency for Facebook's content versus others. So I think at a very first level, it would be eyeballs and efficiency of their caches. And then then there's a whole bunch of other reasons. And one thing I'll add too is you might have a network that might have significant amount of traffic, but actually network engineering decisions on the level of their transit provider might make it look like that traffic that might be, for example, coming out of Malawi is coming out of South Africa. And so the network can't prove that they actually have that traffic. So there's a couple of different things that go into why that happens.
Thank you very much. And Rajiv, sorry to cut you off there. If we could take some of those questions that were popped into the chat and answer them in the chat, Innocent, if you could take a look, that would be fabulous. We're going to head over to Jihong Luo to make sure we are back on track. Jihong, you are up. I'll do the slides. You can speak here. And you'll see your slides here. Yeah. You're super prepared. Thank you so much.
Okay. Thank you, sir, for being here. My name is Zi Hong. I'm a PhD student at UC Berkeley, advised by Professor Scott Shenka and Professor Silvia Ranasamy. And really excited to be here to share this initiative, be part of this initiative to bring global internet access to everybody. And for our group, we have been working on innovating on cellular architecture for courses that we strongly believe in. And today I'll present one of these efforts, which is democratizing cellular access with Cellbricks. And this work was published in the SICON conference. And then one thing I would like to apologize in advance that I have some animation in the slides, which I'm not sure what it's going to show or not on the deck. So I think I have to rely on my sound check much more when I do it. So if you got confused, most likely it's missing animations. Next slide, please. Yeah, we started this work with a simple goal in mind, which is to grow the 10-inch cellular. Cellular network is getting more and more important nowadays. Globally speaking, over 5 billion subscribers contributing to over 60% of internet traffic. However, despite the growing importance, today's cellular ecosystem is still dominated by a small number of large mobile network operators, MNOs. This monopolistic nature of cellular ecosystem hurts innovation, pricing, security, and ultimately user experience. Therefore, the goal of this work is to try to bring competition to the cellular ecosystem and lower the barrier to entry for new entrants. We would like players other than the major carriers to join the market and profit from providing cellular accesses. And we realize that the key to enable this vision is to ensure that mobile operator with small to medium scale footprints can compete equally within the ecosystem. By small to medium scale footprints, I mean an operator covering a city, a village, a plaza, or even down to a single cell tower. By competing equally, we mean that the user should have no reason to discriminate between two operators based on the scale of the deployment. Instead, we would like users to consume cellular access in a way with any access provider that's available at the location and time without worrying about whether the provider has coverage in other locations. With this goal in mind, we examined today's cellular architecture and realized that this is fundamentally at odds with this vision of empowering small-scale access providers. And in the next few slides, I will tell you exactly the reasons. And before we get started, I would like to clarify some acronyms that we use in today's talk. MMO, as mentioned earlier, stands for mobile network operators, and I'll sometimes use operator or access provider for it. NVMO stands for mobile virtual network operators like Google Fi, and I'll sometimes use the word virtual operator for it. And UE stands for user equipment, and I will use the term user to refer to either the user or the user equipment, depending on the context. Next slide, please. So there's missing in animation, but Here, this is an example of illustrating how today's users use serial services. Here we show two operators, both of them have large deployments. For user to obtain serial service, the first thing you need to do is to sign up with one of the operator and establish a contractual relationship. And this contractual relationship and trusted relationship will then allow the operator to perform a set of user management functions, such as AAA, authentication, authorization, and accounting. And then after having this contract with the operator, the user can now attach to the network with the authentication function implemented at the management plan of the operator. And the user is then assigned with the IP address and can go to internet. And later, when user moves to a different location within the coverage of the operator, the network is responsible for migrating user from one tower to another via handover. And such a handover is usually done with in-network coordination between cell tower as well as the cellular core to essentially make sure that the user's IP address remain unchanged and the user's connection can be maintained. And this is usually referred to as a seamless mobility experience that cellular network provided. And lastly, when the user move further away and out of the coverage of its operator, assuming that its operator have a roaming contract with the visitor operator, the user can roam into the other operator's network. And roaming essentially allows an operator to kind of expand its coverage, but a potential downside is the user is usually assigned with a different IP address because it's hard to maintain the same IP address across carrier boundary. And this changing IP address can lead to service disruption because for traditional transport protocols like TCP, IP address is the unique identifier of the connection. However, this is not a big issue today because most of the carriers have large footprints. Therefore, roaming happens pretty rarely, so users mostly enjoy seamless mobility experience. Can we move on next slide? And for virtual network operator, although they introduce a new business model, it doesn't really change the underlying serial architecture. The only difference here is that instead of the user signing up with the operator, you sign up with a virtual operator. And the virtual operator then contract with multiple operators and offload most of the cellular operations, including the in-network mobility support. And here, I would like to point out two key properties of today's serial architecture. First, in order to achieve broad coverage, they rely on pre-established trust. This means that user can only use this network that they have contracts with, either directly, which is the case when you use your own operator's network, or indirectly, which is the case when you roam into other operators' network, or you are using an NVMO service. Either way, a pre-established trust needs to happen. And second, in order to support seamless mobility, today's architecture rely heavily on in-network coordination. And unfortunately, while these two properties serve pretty well for operators with large footprints, neither of them support small-scale access provider. Next slide. To see this, let's see this example where what will happen when we have a large number of small access providers. In this case, we show 4 of them. And let's see whether we can use first, let's see whether we can use existing method to achieve broad coverage. Here, if we follow the convention, have the user sign up with one operator. Because the operator itself have very small footprint, in order to provide user with satisfactory coverage, you then have to contract with all the other small-scale access providers. And this incur high transaction costs of manually establishing all this agreement, and it's clearly not scalable. Next slide. And virtual operator doesn't really change this. The only difference is that instead of operators establishing pairwise roaming agreements, the virtual operator now need to go ahead and establishing all the agreements with small-scale access providers in order to provide good coverage, and still incur transaction costs, and it's not scalable. And next slide. Okay, so the existing method doesn't allow us to support broad coverage for small-scale access provider, and they do not support seamless mobility either. The reason is because when you have a large number of small-scale access provider, moving users frequently cross the boundaries of different carriers. And as mentioned earlier, this will incur frequent IP changes and therefore lead to frequent service interruptions. So you won't be able to easily have seamless mobility unless you assume some sort of tight in-network coordination between all the operators, which is not scalable when you imagine a large number of small access providers. So the conclusion is today's cellular architecture can provide nice small operators with neither broad coverage nor seamless mobility. Next slide. Realizing all this issue of the drawbacks of today's architecture, we propose a new cellular architecture named Cellbricks, which will try to make sure that we can scale to a large number of small-scale access providers. And in here, next, I will briefly talk about how we can arrive at the Cellbricks design step by step. the first design decision that we make in Cellbricks is to start from the NVMe architecture. Basically, we believe that decoupling service provider from access provider is a great idea because it makes sure that the user is no longer bound to any small scale providers. Because of this, we introduced broker, which is a similar entity to NVMe, but with different functions. And the operators in our architecture is called btelcos. And this because it will become clear that they actually serve very fundamentally different functions compared with operators today. And then starting from NVMe-based architecture, we depart from it to support broad coverage and seamless mobility. First, to support broad coverage, instead of having the broker establish contractual relationship with all the small-scale access provider, we embrace an on-demand and untrusted relationship between them. By untrusted, it means that the broker does not need to have any contracts with the btelcos beforehand. And by on-demand, it means that the broker only interacts with the btelco and establish a relationship when the user requests to attach to it. So it's on-demand and untrusted. And what we realize is that in order to support this on-demand and untrusted relationship between broker and btelco, we need to have architectural changes. Because now that the btelcos, or AKA the operators, are untrusted, we can no longer count on them for user management tasks such as authentication and accounting. Therefore, the first design decision that Cellbricks make is to next slide is to offload the to move the user management function out of the network into the broker and the UE. And by doing so, we basically have the broker and the UE performing functions like authentication and accounting, and then we'll be able to use all the small-scale access providers in an on-demand and untrusted fashion. So this is the first part of the design, which is to move the user management out of the network. And the second part is about the mobility parts. As I mentioned earlier, when you have large number of small access providers, moving user frequently cross boundary of them, and you incur a large number of IP changes, which is really hard to address within the network. So what we decide to do is to embrace IP changes and essentially expose IP changes and let the end host handle IP changes. Next slide. So basically, we also move mobility support out of the network into end host. So instead of relying on the network to hide the IP changes, we rely on end hosts to explicitly handle IP changes with protocols, for example, like MPTCP and QUIC, that are capable of maintaining connections during IP changes, and try to ensure that by trying to provide seamless mobility, even though we have no coordination between btelcos, and try to and be able to scale to a large number of btelcos while maintaining good mobility experience. And next slide. This is basically a Cellbricks architecture at a high level. And to recap, the goal of the Cellbricks architecture is to enable on-demand cellular access from any available access providers by not requiring any pre-established trust with btelcos and not requiring any in-network coordination between the btelcos. And we believe that Cellbricks can bring substantial potential benefit to the cellular ecosystem. First, it will lower the barrier to entry for the new entrants. For for btelco, you don't need to establish contracts. You don't need to worry about mobility. All you need to do is essentially to set up your cellular connectivity within your coverage, and then you can profit from providing cellular access. And then because we allowed any user to use any access providers, we allowed a more efficient use of cellular infrastructure and provide user with higher cellular availability, because now you can connect to any access provider instead of provider that you have pre-established trust with. And lastly, we simplify the cellular core essentially by moving the user management and mobility part all out of the network. And with all this potential benefit, I think a natural question that arises is Cellbricks technically feasible? Next slide, please. And we believe that the answer is yes. And with our research, we show that Cellbricks benefit come with a minimal performance overhead. Next slide. Specifically, to show the technical feasibility of Cellbricks, we propose 3 technical pieces to address 2 main technical challenges arise when you try to realize an architecture like Cellbricks. The first challenge arises is that how do you support user management functions without pre-established trust between a broker and the btelcos? Here, we have 2 protocols. First is a secure attachment protocol, which is based on public key-based authentication to be able to authenticate untrusted btelcos. And the second protocol is a verifiable accounting protocol, which we embed measurement function into the user spaceband so that we can obtain accurate accounting results, even though the underlying btelco is untrusted. And the second part challenges come from how can we support seamless mobility without tight in-network coordination. And here the idea is to propose what we call host-driven mobility, where we leverage protocols like MPTCP and QUIC, which essentially have a unique connection identifier other than IP address for each connection to maintain seamless mobility experience when user crosses boundaries of carriers and incur IP changes. And to measure the performance of cell bricks and overhead of cell bricks, we have two experiments. One, we build a small physical test bed, and we measure the attachment latency under this test bed. And the other one is that we try to emulate cell bricks host-driven mobility approach with existing network, and then measure different applications performance. And in both, without going into detail, in both of the experiments, we show that the overhead is actually minimal. Next slide, please. We discussed more in the papers about the detailed design of and evaluation of cell bricks related works, as well as some open questions such as the business incentive and the market structures of cell bricks. Next slide. But today I'll briefly talk about our answers to some of the adoption related problems, because it gets asked every time when we present this work. Next slide. The first question, usually people ask about spectrum. There are 3 points we like to make about spectrum for cell bricks. First, cell bricks require no changes to the RAN. So it doesn't depend on policy changes on the spectrum policy changes. Instead, essentially, B telcos can use any spectrum available to them. Cell bricks doesn't really regulate or care about that. And the second thing we'd like to mention is that trends in the spectrum regulatory environment actually we believe are favorable to cell bricks. There's CBRS, which is a dynamic spectrum sharing scheme that allow you to use spectrum without having exclusive license to it. And there are also some regulatory constructs that allows you to operate in some license but unused cellular spectrum. So we believe that the trend is favorable in the sense that B telcos should be more easily get the grab on some spectrums. And lastly, we believe that a franchise model where the existing MMO lease spectrums to some B telcos can be beneficial to both parties under some situations. Next slide. And the next part of the question usually people get asked was, what about the incentive for different stakeholders? We believe that incentives are clear for B telcos and brokers. Essentially, this is an opportunity for you to join this market, this growing and profitable market. And then Cellbricks, what it does is to basically lower the band entry, make it more easily accessible. And for the user, we believe that you will, at the beginning, benefit from improved coverage, and ultimately will benefit from a more competitive cellular market in terms of both pricing and security and all that. I think the story got more complicated when we come to incumbent operators. On the one hand, we believe that there are situations where operator can benefit from their ownership spectrum without actually have to spend all the money to deploy the cellular architecture in some cases. But on the other hand, we do believe that most of the incumbent operators do not like these ideas like Cellbricks, which in some sense is challenging their monopoly as well as their control over their users. But one thing that we'd like to point out is that Cellbricks, you can deploy it incrementally with no changes, no cooperations from legacy operators. Basically, we're not seeking their help, and so it can be incrementally deployed. Next slide. And lastly, will brokers be the new monopoly? We believe no. The answer was, the reason is that the barrier to entry to starting a broker is actually pretty low. You don't need investment on cellular infrastructure. You don't have long-term agreement with B telco. Everything on demand, untrusted, as mentioned. The main requirement is really for you to have the ability to attract users and provide good customer services and the standard functions like authentication that are usually provided in web services. And we believe that there are a large group of companies or organizations that are qualified to perform these functions. And moreover, it's really easy for users to switch brokers or even sign up with multiple brokers, given that broker essentially operate over the top. Next slide, please. Here, I'd just like to briefly comment that we believe that beyond Cellbricks, there are actually a lot of research opportunities to innovate on cellular architecture for different purposes that we believe are very important. For instance, the same insight that we leverage in this work, where we essentially have user host-driven mobility and have decoupling moving the user management out of the network, we leverage the similar insight and extend it to support practical location privacy. Essentially, in this work, LOCA, which was published this year in NSDI, we show that you can preserve user location privacy without compromising the network's ability to provide users with services based on their identity. And the insights is really similar to what we leverage here in Cellbricks. And we're also exploring different ways to kind of redesign or innovate on the cellular architecture to improve the cellular efficiency, the infrastructure efficiency, so that we can actually to meet the ever-growing user demands and try to have, allow the user to more easily access to use different access technologies. And last slide. And in conclusion, in this work today, I present Cellbricks. Cellbricks is essentially a radically different cellular architecture with the main goal of lower the barrier entries for new operators. And while doing this, we also enable a simpler and more efficient cellular infrastructures. And to achieve this goal, we essentially make two important choices. The first one is that we decide to move user management completely out of the network and into the broker and the user equipment. And the second, to support broad coverage. And the second one is that we move user mobility support out of the network and move it into the end host. By doing so, we can support seamless mobility without any in-network coordination between B telcos. And we show with evaluation that Cellbricks is technically feasible with minimal performance overhead. With this, I wrap up my talk and answer any question that you may have. Thank you.
Wow, perfect timing. Okay, I believe we have a queue all set. Hang on one sec. Thank you, Jihong. That was excellent. Rajiv, you are at the top of the queue. Over to you.
Hi, Jihong. Excellent presentation. A very interesting, approach you have taken to uh, achieving those targets of lowering barriers to new operators getting into a market. That's always been something that's uh, you know uh, everyone thinks the two worst industries to get into are telecommunications and airlines because of the absolutely huge costs involved in getting initially set up and running. But I wanted to contrast your technology driven approach to lowering those barriers to approaches that are currently being taken by some countries. The example that I like to use is Malaysia, because I've seen a little bit of how they're trying to do it, where they're basically saying, hey, if these are the challenges, getting efficient and widespread access networks is probably the biggest cost for a new operator coming in. They are basically mandating that the entire 5G spectrum will be owned by a single entity who will operate a common access network, and that entity will not operate as a carrier or provide end user services. So they will purely be a service provider, and pretty much every carrier in the country then becomes an MVNO that runs on top of this common infrastructure. But whoever is managing and administering that common infrastructure does not compete with the MVNO. So every carrier can then only compete on um, their their own product. That is their the plans and whatever other features they want to compete on. They're not actually competing on the access network side of things. Like basically every carrier, even the one who just started last week, has basically the same level of coverage.
Oh, go ahead.
That's a great data point. I wasn't aware of it. I think it's definitely a very different approach, and I will definitely take a look at it. But I think the ultimate goal was in terms of contrast, I think it's quite a different vision. I think in Cellbricks, the vision is, as we work more towards it, it's really more similar to, in some sense, very similar to Wi-Fi, where you are at a location. Let's say you own a house, you own a factory. It's really easy. You have all the equipment ready, and then it's really easy for you to just set up. We want to make it easier for you to just set up cell towers, and then just be able to profit from a large group of users, basically any user. That's the ultimate goal. But I think there may be also possible to reach that goal with the approach that you mentioned in the data point. But I think I need to read more about it in order to comment on the
I
feasibility.
search you read up on an organization called DNB, which is the organization that's been set up and mandated to do this in Malaysia. You'll find a lot of interesting reading material about them.
Yeah, thank you. I will definitely take a look. It's very interesting. Thank you for the data point.
Yes, thank you, Rashid. Sounds like a structurally separated network, which the UK often promotes. Alistair, you are up.
Alistair Woodman, NetDev. Yeah, so I I assume that the technology works as described. So, and I understand enough about 5G networks to figure that out. And tell me if you've written this down from the business logic side in your paper, but I've seen these class of discussions before about sort of either opening up and making access things available, and they run into all sorts of sort of ugly corner case problems associated with peak time usage, event usage, other types of things. So you end up with this situation of my want is not your need, in the sense that you have a lot of people who would like to get access to a particular resource at a certain time, but the entity that's providing a service, and they may be providing a marginal service because there exists other players in the marketplace, are going to be overwhelmed at the time when lots of people want access to their service. So the description that you're describing about providing a marginal access advantage sort of works in the default assumption case where you don't have any large spikes between peak usage, other types of things, but they fail dismally in the situations where you have different variegated actions. So I used to work long time ago with voice over IP stuff, and there was this concept called free world dial-up where people would provide their E164 address numbers to anybody on the planet. And it sounded like a great idea, but the three people who put the resource up in New York always had busy lines, and because everybody wanted to call New York. And so I see the same fatal class of problem with too much demand, and I don't know how you solve that. Because if you're trying to arbitrage cost out of the system, which is a good thing, it means that people are making less money everywhere, which you can argue that some people are making too much money. But if you then make things more marginal, you end up with them not being able to cover their peak costs. And again, this is a common economic problem type of thing. You may have thought about it, you may have not thought about it. I'll stop talking there, and you can tell me, we can talk over offline.
We can definitely talk more offline. We essentially kind of, there's definitely a series of economics problems that are associated with structures like Cellbricks, and we definitely don't claim to have an answer to all of that. But one thing I would like to point out that I think can be relevant was you mentioned peak usage. Basically, how can a collective of small-scale operators provide good services when there's a surge in the user demand? There's an ongoing work actually in our group that we believe that, really fine-grained sharing of infrastructure between operators, the fact that you can use any operator near you, because there may be, when there's a peak, it's likely that one of the operator is overwhelmed, while the other one has some leftover capacity, like really transiently happens. So if we can enable them to kind of like shift that, like to do basically more fine-grained statistical multiplexing, that may be able to help with that a bit. But it's not really, it doesn't relate to economic, but it's just something that our research group have been looking at. And I'm interested to have a conversation about the economic side of the story. In the paper, we essentially say that we're researchers. Give us a break. so I think that's pretty much what we say, because yeah, I think there will be some issues, like for example, like where the incumbent operator be willing to be like essentially a pipe. They will no longer have a control over their users. It's a complex problem. Yeah.
It's worth taking a look at to Utopia networks in the US and some of the others that are doing the structural separation.
Yeah.
Yep. Okay, thank you very much, Alistair. We have Julius up, and Julius, I'm not going to attempt to pronounce your last name. It looks really interesting. Can you say it for us so that I don't?
Julius Krobacek.
Voila. Okay, Julius, you're up.
And so perhaps I didn't understand this well, but are you speaking of an architecture in which the mobile node's IP address changes routinely?
Could
So-
you say that one more time, Julius? We just had a
Okay.
little bit of a light. Your voice came through very faintly. So if you could say that, get a little bit closer to the
Okay, yeah.
microphone.
Is it better now?
Yes.
Is it perhaps better now? Okay, so my question is, are you envisioning an architecture in which the IP address of the mobile node is changing routinely?
Mm.
Did I get that correctly?
Yeah,
Yes?
we imagine we imagined that at least when you cross the barrier within each B telco, you can do in-network mobility, so maintain the same IP address, the same they do. But when you cross the barrier, we imagine that across the boundary, we imagine the IP address will change. They may not
Okay,
change.
so
but we
what
assume they will
that means is that essentially you're moving the cost of mobility from the lower layers to the application. So every single application needs to deal with the issues of mobility. And so there certainly are techniques that allow you to do that. The best known is probably multipath TCP, which has been recently promoted by Apple, which is originally from Brussels, from Belgium. But they are not widely deployed. And I'm wondering whether you have considered the issues it will cause for application developers or for users for whom many applications won't work well in such an environment.
Yeah, that you are exactly right. Basically, what we propose to expose the IP address changes, the mobility, what you say, to a higher level, maybe handled by the transport layer, or maybe even higher up by the application layer. And then we agree that I think for MPTCP and QUIC, basically the transport protocol, whenever they have a migration ability, or basically they have a connection identifier above IP, they're able to handle it. But they are definitely not like 100% deployed. So there are definitely cases where it's not. Where it basically, and then what we show here was that we show in the evaluations that when we evaluate with MPTCP, and so that can handle when IP changes, and we measure like application performance what we try to do is that we change IP every single cell tower, and it turned out surprisingly that the performance overhead is really not big. And the reason was that a lot of this mobile application, they already built with this assumption in mind that okay, wireless network is not the bandwidth is not stable, so they have large buffers, and they have taken a lot of action to handle this kind of abrupt changes in terms of the throughput that they can shift or things like that. So as long as you can kind of like mask the IP changes and quickly ramp up your throughput or your throughput, the performance overhead is really, really very small. So I think one thing that we try to argue here was that maybe it's time to just like not do all the heavy lifting within the network and just expose it and let the higher level handle it. And then that will in return have give us a more scalable and flexible architecture, modular architecture like Celtics. So I think I agree with everything you say.
So I agree with what you're saying, that it is nice moving it up, but I would just like to point out that it's an open research problem, and that's not a solved. That's not something that has been solved yet.
Yeah. Thank you.
Thank you, Julius. We're going to close the queue, and I'm really sorry, Rajiv. We've got to move on to the next presentation. So thank you so much, Juhong. That was excellent.
Thank you.
Bharath, you are going to be up in 2 seconds on computing within limits. So Bharath, over to you.
All right. Can you all hear me? Hopefully everybody can hear me. So
could you get a little bit closer to the microphone? Yeah. Oh, you got it on. Yep. And maybe we could ask the MeetEcho folks to crank up the volume. Thank you.
All right. So I'm going to talk about something a little bigger picture, a little bit weird, and for some of you who were at the human rights group discussion from last year that Mallory had invited me to, very similar topic. I mean, basically, I'm going to talk about the same thing. It's something that I've been talking about in a lot of places, which is, broadly what we're calling computing within limits, something that we've sort of built up a community of researchers over the last 8 or so years. And let me see if I have control over the slides, or no, I don't.
You can just ask me and I'll forward them.
Okay, yeah, let's go to the next slide. So I've been working on the topics that are related to Gaia for, about 10 years or so, internet connectivity and networking for long before that. But simultaneously have been concerned about broader questions societally and ecologically about where we're headed, what can be done, what should be done. And I think these are probably my old slides. So the real question that I've been asking myself as a networking person is, or maybe a reframing of this is really that networks are how we organize our societies. And so it's not just a matter of connecting to the internet broadly, but what is that internet that we are connecting? What is that network we are connecting people to? And for what purpose? What are they going to be able to do with that internet? And it can be at the level of, we don't want zero-rated walled gardens as the only thing that people are able to connect to. That's sort of a first step. We want to say, okay, we don't want zero-rated walled gardens. We want something more expansive as the network to which we are connecting people. But I want to think even beyond that, to think about global challenges that we face. Largely in the computing within limits community, it's been about energy and resource and ecological challenges. And then I want to step back and think, what are the unique skills that we bring to the table as networking people, as systems people, that especially the Gaia community and the ICT4D community have that perhaps the broader networking community does not have an awareness of or a focus on. So next slide, please. And so let's talk about limits. Next slide. So, when I started this journey for myself, something around 2008, 2009, sort of thinking about what's the role of computing within limits, and limits being all of these different types of energy and ecological limits, the natural place to start was always how do we use energy and what are the consequences? Next slide. And, the first thing that everybody focuses on when we talk about computing is, well, we use a lot of electricity, so let's try to make things more efficient. But it's long been known in ecological economics that efficiency doesn't always work, right? If there's, what they call rebound effects, it's been a phenomena that's been demonstrated over and over again. And we, unfortunately, in computing have been demonstrating this, which is that by making things more efficient, frequently, especially when the economics are aligned in certain ways, you end up with more usage rather than less, because it's now decreases the cost sufficiently that it brings new uses online, which then increases demand. And so increasing demand of computing, increasing demand of energy as a result is harmful, as we know, and we have limited energy resources. And so it's a question of, okay, well, what's the role of computing folks who are interested in these kinds of problems? Next slide. And so the next challenge that, of course, people turn to, and I spent some time thinking about and looking into, is what are the questions around climate change that computing folks should be aware of and thinking about as we do our research? Next slide. And this slide, I'm sad to say, I made in 2008. And when I was preparing for this, I thought, oh, should I update it? And I thought, no, there's no need to. It's exactly the same, except where we are in the slowly boiling frog situation has changed a little bit. There was less urgency and less worry about it when I presented it to students and researchers in 2008 than there is now. But still, not all of us are really working on questions related to the future of the planet. Next slide, please. And there's lots of research going back again quite a ways that the way that business as usual is operating is not going to cut it in terms of actually avoiding what climate scientists are generally calling "quote unquote" dangerous or catastrophic climate change. Right? There are these various red lines that they've drawn, and we're already seeing that perhaps the red lines aren't even sufficient in terms of how conservative they are for mitigating the worst or particularly bad climate impacts. Next slide, please. And so we are always faced with these choices that we present both to the public at large and to us as practitioners. Computing folks can say, well, We can try to get users or individual people in the world to change behavior. Maybe computing can play a role in that. We can try to help them use fewer resources, less resources. Now, in the Gaia community, and the ICTD community, there's this interesting dynamic, which is that the focus is largely on the global population that is already using very little or is using less than those in the wealthier parts of the world. So is it really the right choice to say, well, we need to have those users, those folks use less? But the flip side is that we actually have a better understanding of what it's like to build systems and build, if networks are how we organize our societies, build societies that can use less and still have good lives. And then, of course, changing sources and finding more is not really something that us as computer scientists are going to really solve the problem there. Next slide, please. And so, often when I talk to technically minded folks, they say, oh, well, we've got lots of alternatives. We can find other energy sources. We'll power our computing some other way. And this is from Tom Murphy's excellent book on the topic, where he considers, what are all the different alternatives? And next slide, please. It turns out that, fossil fuels are used for a reason. They're actually really useful. And so it's difficult to easily move off of them, even though, change is happening slowly. Next slide. And so we're always hoping for a miracle breakthrough. And that miracle breakthrough has been promised for a long time, since when I was a kid. And, still today, there's always a new headline that we can hope for. But, we're still hoping for that miracle breakthrough while everything slowly grinds down. Next slide, please. So, there's this power profile that Saul Griffith had presented back in 2009 that said, okay, well, we can decarbonize our global energy system in this way that will be far more efficient and uses a little bit of all the different technologies that are out there. Next slide, please. But even if we were to attempt to do that, and we were to try to build all of this capacity as fast as possible, and this is an estimate of how fast you would have to build. This is literally 100 square meters of solar panels built and deployed every second globally, sustained over 20 years, just to get that 2 terawatts, et cetera, down the line. Next slide. It turns out that we don't quite have the manufacturing capacity to do it, even if we wanted to. We're, from a third to maybe far less than that for many of these different technologies. Next slide. What we end up with is, even if we wanted to try and do an energy transition and sort of decarbonize not just computing, but society broadly, this crash program, this rapid transformation would be short the amount of energy that's needed by sometime in the sort of late 2030s when this program would end. So after doing all these calculations, and I recompute these numbers every few years, and it basically looks the same every time, that we're in this funny situation where, as computing folks, we command so much attention, so much control over the global economy. When we introduce networks into places, we are, in a way, structuring the societies that we are introducing those networks into. And this is one of the most fundamental transitions, as I see it, that we have to grapple with, the energy and climate situation. And the question is, what are we going to do about it? Next slide. And so, I often, when I started learning about ecological limits long ago, I turned to sort of the classic studies, right? Limits to growth and other classic studies, which of course didn't make predictions, unlike what was sort of popularly believed, but rather did a bunch of simulation scenarios and said, okay, what if we had more resources, fewer resources, different types of scenarios, and largely found that, we end up in one of two situations. One where we have fewer resources, or we constrain the resource availability, and we end up in a resource crisis where industrial output and all the other sort of markers of industrial civilization run short of the resources they need. Or next slide, we have a greater resource base, and then we end up in a quote unquote pollution crisis where we overshoot on the pollution because we are able to use those resources, and then we damage our agricultural base and ecosystem. And it seems like we're smack in the middle of these two right now, and we're trying to decide which way to go. And neither of those seem to be appealing options to me. Next slide. And so, this has been known for a long time. Carter talked about it here in the US in 1974, that, we have to make these changes in a planned and rational way or have it be forced on us by nature. So there's this question that this idea that we need to plan for some sort of post-industrial system has been around for a long time. Next slide, please. And so, returning to these questions of where are we headed, what can be done, and what should be done, and this is really more of a personal story. It's a personal journey for me, and I've been talking with a lot of networking systems and broader computing colleagues about it for some time, of what should we be working on? What's the most useful way that I can spend my time, given the skills that I've acquired as a networking and systems person? Next slide. And so, I often thought about the split between sustainable computing versus computing for sustainability, right? So we think about, okay, if we want to construct sustainable societies, of which networks are one part, but networks are enablers of broader changes in society that will be for sustainable societies. It's not that we do want the networks that we build to be sustainable. We want them to be energy efficient. We want them to be as low waste and sort of fit into a circular economy. But networks are just very small piece in terms of the energy footprint, the material footprint, but they connect so much more, right? They enable resource flows. And one of the things I often think about is, in some of the early rural internet access work I did, something like 10 years ago now, this was in a community in far rural Northern California where people didn't really have much connectivity. So people were on really bad satellite, or they were on 9600 baud dial-up. So they didn't really use the internet very much. They used it to get email every once in a while. So we brought connectivity, standard, wireless ISP sort of architecture. We had written a paper about it at Dev, a number of years ago. And one of the things that changed very quickly was that now they were all ordering stuff off of, e-commerce sites, Amazon and others, because they could, whereas they couldn't do that as easily before. And so the network changed other networks, right? It changed the internet connectivity, of course, changes the economic networks. It changes the social networks, not the online social network, but the actual on the ground social network of a community. And so we shape so much more just through the connectivity that we have. And so back to this idea that networks are how we organize our societies, computing for sustainability and networking for sustainability can be about how does networking shape the creation and organization of a sustainable society. Next slide. And so really what I concluded is that I want to weight my work 95% in the latter bucket and for sort of 5% in the former bucket of the work that I do of this type. That really I want to think to, how am I helping create a sustainable society through the networking and systems perspective that I can bring to the table. Next slide. And so, the first place that I started, and this is where my focus has been on agriculture, but there are all sorts of other large sectors of society where the networking and systems perspective, especially the sort of ICTD-inspired Gaia networking perspective, would be extremely valuable. So in agriculture, my focus has been, just as a brief, totally unrelated topic to what Gaia folks normally think about, it's been on, instead of taking an optimization-based approach, which is the way that I think somebody who comes from a machine learning background or an AI background might come, and some of my colleagues do, come to this question of agriculture and they say, well, agriculture is damaging the planet in the following ways. Let's say we're spraying too many pesticides. Let's take the data from the farmers and we're going to run some optimization algorithms. And look, we found a way to spray fewer pesticides on the crops. Isn't that good? Maybe, but it also reinforces a system that is unsustainable. Instead, if we take a systems perspective, we can think of, and so a recent paper we had is on how do we take some of the work that was done in the networking community on, say, header space analysis and searching large state spaces, and go from that to reconceiving how agriculture can be thought of as a state space search problem, which then allows us to merge two areas of agriculture, which are agroecology and precision agriculture, that previously had not talked to each other. So this is some work I've been doing with some agriculture colleagues. And there are systems perspectives that we can bring to bear that others don't have, and that can actually be useful in sort of advancing sustainability and sort of a limits-aware approach in other fields. Next slide.
And Bharath, we have about 3.5 minutes left.
Okay, well, I'm almost done. So, and then, there are all sorts of other areas in which, we can apply ourselves and our networking and systems perspectives. And so, really what I'm trying to do is encourage everybody to think about this question of, if networks are how we organize our societies, how do we want the networks that we build, not just the bits flowing over the wire and the interconnections that we create, but the networks that will be built on top of that? How do we want those to evolve over the next few years? Next slide. And, then we want to think even bigger. How does this shape culture? How does it shape the perspectives of those who are part of that culture? We need to be flexible as things are changing rapidly. And, as some ICTD folks have long said, we need to be cultivating wisdom as the sort of the key resource among societies. Next slide. And so I'll just leave this up here and we can take questions.
Questions for Bharath? If no one has one right away, I have a quick question.
Sure.
Bharath, this is more of an integrated systems approach, yeah?
Sure, yeah. I think that'd be accurate, yeah.
Yeah, I was just thinking of all of the push now to build more broadband networks and the billions of dollars that went out there, but nobody had an integrated policy approach and also a financing approach for those networks to be developed and electrical grids to be expanded. There's thought that's gone into it, at least in the US, but not enough, because we could really create more efficiencies for network rollout if the networks were more efficient, but also, as everybody in the room who knows, there aren't a lot of electrical grids in certain countries, right? And so anyway, there's lots that could be integrated there. But
Absolutely.
Any questions for Bharath? Anyone else? And Bharath, your email is on the presentation, correct? Oops, hang on. Jane's not looking at the queue. Okay, Curtis, you were in the, no? Okay, so Bharath, I don't see anyone in the queue. Your email's on the slide deck. Oh, Curtis, go ahead.
Yeah. So I liked, obviously, the work. People don't know. Bharath was on the found. This whole topic is, to me, very interesting in exactly these ways of the ways that networks interact with the systems around them. How do you feel about, so Bharath, how do you feel about all of the kind of efforts towards more local connection-y stuff? Like, having been doing this for so long, it's never really worked. And that, connecting people to Amazon seems to be a fundamental piece of what the internet does. Is there another world, or do we just need to work in that space where that's what the internet does and people still really like it?
Yeah, that's a good question. I mean, I think that taking that problem on directly sometimes is a question of the economics of Amazon and, marketplaces that are like Amazon, and less about something that we as networking people are going to be able to shape directly, at least in my mind. Because, if we're going to connect people to the internet, we're not going to connect them either. We're in the sort of walled garden world of zero rated services, which is a whole different discussion, or we're in the world of the open internet where people are going to go use whatever's the cheapest and biggest retailer out there, say. I guess I'm thinking about how can we use the same skill sets that we apply, the intellectual skill sets that we apply to, say, building decentralized cellular networks or improving IXP connectivity in some region. How do we say, okay, we want to decentralize other kinds of networks, not necessarily computing networks, although, of course, the computing piece of it will always be present because everything ends up having an actual internet connected and computing based network in it. And so that might be, the urban networks, right? So there's people who are working on, urban redesign of various types and decentralized urbanism. That could be something where there's actually an interesting role for networking people to apply their skills. And that's just one, and I've mentioned the example of agriculture. That's one where, it requires embedding ourselves in communities that are adjacent, that are philosophically aligned, but that do not have our expertise. And then we can say, let me understand what you're doing and see how we can apply our skills there.
Thank you very much, Barath. That was an excellent presentation. And folks, take note of Barath's email in the doc if you want to reach out to him. Thank you very much. We appreciate your presentation. Naveed, you're up next. Give me a sec. You want to introduce yourself?
Can you hear me?
We can hear you. Go for it. Your slides are being shared now.
Excellent. Thank you so much, Jane. And hi, everyone. This is Naveed Haq from Internet Society. And it's really good to be part of this meeting. I've never actually have been part of this meeting in IETF, and it's really good to know that there are efforts happening within IETF as well to discuss the internet access, which of course is an important thing. My background had been as an internet engineer 22 years back, but then I came into regulatory and policy space, and now I have a key passion to connect the unconnected. And fortunately, working for Internet Society, I'm able to practice my passion through some of these community networks, and one of those is what I'm going to present today. But before that, I would just like myself to go back to 20 years when I was working for the Pakistan Telecommunication Authority as a regulator. And remember, it was same time in 2003 when we were very excited to know that we are going to deregulate our market in Pakistan, so we can break the monopolies of incumbent, and people are not relying only on copper, but rather the new mobile 2G, 2.5G networks are coming in and will open the market for the players. So we can provide internet access, mobile internet access to people, and then we can, meet the dream of connectivity. Unfortunately, 20 years after that, I'm talking to you about this presentation where still half of the world population is not connected, although there have been a lot of improvements beyond that. But what has been the basic reason why we have not been able to connect even in Pakistan the whole population in 20 years of this mobile internet revolution? And some of the reasons that I believe are connected with the commercial nature of internet service, which is connected with the investments of the mobile operators or the telecommunication operators. One, to acquire a license, as someone was saying earlier, perhaps Rajiv, telecommunication is one of the most difficult market to get into. And second, once those rollouts were happening, the mobile operators or the new telecom operators were focusing, of course, in the tier 1 cities, and then tier 2 cities, and then perhaps the tier 3 cities. And by the time they went to those tier 3 cities, they got to know that there is a 4G or 3G, and now 5G is coming up. So then they have to again invest into that user base which lives in cities or towns, where they get this ARPU, ARPU, as I remember we used to call it, the average revenue per user. So eventually, in the nutshell, everything comes back to how much money a user is able to give back to a mobile operator. Uh, and that to me still remains the reason why we see half of the world population not connected, mostly of those living in rural and remote places and villages where perhaps a telecommunication operator is not interested to invest because there is no ROI. Um, some of the work that we do in terms of bridging that connectivity gap is through small networks which are built by, for, and with the communities around the world. And one of these network that I've built recently is in the mountains of Himalayas near the Mount Everest, uh, where this community known as Sherpas are the people who have Himalayas as their home for hundreds of years back from Tibet. They migrated into Himalayas, and then since then they call this their home. This guy whose photo you are looking at is Tenzing Sherpa. He is the first human, along with Sir Edmund Hillary of New Zealand, who climbed up to the Mount Everest back on 29th of May 1953. And once this guy actually did this as the first human who climbed Mount Everest, the Sherpa people got very famous actually. And people got to know that there are these people who are living in mountains near Mount Everest. So this project that we did is for these people known as Sherpas of Nepal. Next slide, please. So this project is deployed in two villages, Khunde and Kumchung, which are around 32 kilometers from the Mount Everest base camp. At 3,900 meter altitude is where these two villages are located, and there are around 1,800 Sherpa people who are living in these two villages. Next slide, Jane. So what challenges were these people living in these two villages? In fact, I can say that broadly the Sherpa people are facing in these days. One is their source of income is completely dependent on tourism. People who come either want to go to the Mount Everest base camp or want to do a summit. They need a Sherpa guide or a Sherpa person to help them. So that is their key income activity. However, there are a lot of villages, including the Khunde and Kumjung, which are not part of the Mount Everest track, the main track. So which means that the climbers or the expeditors who come here, they don't go to these villages, rather they stay on the main track and they go up to the Mount Everest, which of course does pose a lot of challenges to these Sherpa people living in these villages, because they don't have a direct access to the climbers. So what they do is they depend on people sitting in Kathmandu who are doing marketing or who are selling their services through internet. And once they do get those services from a climber coming from, let's say, Poland, they would hire someone from Khunde and Kumjung village to be the guide and earn some money. The second challenge that these people are facing is the climate change. It is really affecting the overall life expectancy and the safety of these people, where we are hearing a lot of various climate change happening in the glaciers up in the Himalayas near Mount Everest, which does affect, of course, the life and the livelihood of these people. Next slide. The second challenge that we see, and that I already told, was the remote location challenge. Since they are not part of the mainstream Mount Everest trek, these two villages are very much underdeveloped, particularly in terms of the internet access. I recall the first time when I went to this village, I had to walk around 10 to 15 kilometers to get a mobile internet signal. Uh, and then when the mobile operators say that they have a 95% coverage area, that is the problem, because that coverage area includes these kind of remote places as well, where perhaps you have to walk sometimes few kilometers to even get a signal that you can use to send a message over the internet. Now, since they don't have internet connectivity, they had no opportunities of education, healthcare, and other digital opportunities. So what we thought as Internet Society is to build up a small network which can help these Sherpa people to get online and explore what kind of opportunities are waiting for them. Next slide, please, Jane. So the solution that we came up was to build a small Wi-Fi network with a 10 megabit per second aggregate bandwidth. We put this network on top of this small building, which is the local youth club. And then we also connected a local school, which to my surprise were well equipped with latest computers. However, there was no internet. The Sherpa girls and boys studying in that school do have internet as a subject, but again, to me, it was a big surprise that they don't have internet access. They're just reading internet out of their books, and they don't have opportunities to actually experience what internet is. So this small network with the 10 Mbps connectivity did open some uh, ray of light for these Sherpa people, where the school kids have now started to use the internet. And I remember when we opened up the connectivity and we asked the boys and girls in that computer lab to start browsing, the first thing that almost all of them did was search for their own school on Google. And the results came with their photos of their school, which were posted by someone on the internet, and that brought a big smile on the faces of all those kids. And it really felt for all of us who was part of this project a kind of a satisfaction. Next slide. Now, when we deployed this 10 Mbps wireless connectivity, we realized that this would not be enough to cater for 1,800 Sherpa people. It will, of course, help the school, but what about the other larger population, the youth, which actually are not living in their villages anymore? Rather, they're going back to Kathmandu to find some job opportunities, or even some of them leaving Nepal altogether because they don't have enough opportunities, which at least could be filled up through a decent and a stronger internet connectivity. So we decided to deploy a fiber optic network for these Sherpa people. So each of them can have a decent internet connectivity in their homes, and the youth and the women and the older Sherpa people can start experiencing digital transformation, where their dependency on people sitting in Kathmandu could be reduced. So we estimated 100,000 US dollar funding needs. We went out asking for some donors to help us to connect these two villages with the fiber optic connectivity. We did receive some funding, and based on that, we were able to install a fiber optic network in May this year with a total cost of around 50,000 US dollars. Next slide. Now, before I go into the details of the fiber deployment, you can see this photo. This was the terrain in that area where the local Sherpa people helped us to dig down to lay that fiber, which was, of course, a great example of resiliency from the local community. Uh, I want to show a video, if it's possible, to share my screen. Because a lot of us seeing this presentation might find this 20-second video fascinating. Jane, can I share my screen?
I think you can.
Okay.
I just need to figure
No,
out.
I've asked for it's asked send a screen request, screen share request.
Sometimes it's not the easiest thing to do here. Hang on.
In the
Okay,
gray.
it says
Sorry?
I'm hitting the button. Is it not working?
Yeah, go for it.
all the slots of the requested media are already taken. So okay.
Oh, yeah, Jane, you got to close your slides.
Yep, hang tight. Okay, Naveed, give it a go.
Can you see my screen now?
Not yet.
No.
Curtis, can you press the button again? Okay, let me send you another request for screen sharing. All right, perfect.
There you go. Yeah.
Yes. All right. I hope you can see that.
Yep.
All right.
There's no sound, and I know this was an issue that came up recently on one of the lists. Can you narrate, Naveed? And for some reason, it just clicked out.
Oh,
Naveed,
but
you still
did
there?
you saw the video?
We did.
Okay, well, that was what I wanted to show. So that video actually shows the local people carrying the fiber optic cable on their back, and they had to do a walk of around 7 kilometers down from an uphill point where the main internet bandwidth was connected with the fiber optic cable. So what I wanted to show was that we people, including me, who have seen some fiber deployments with the machines and everything, this was really an eye opening for me that how difficult it could be to deploy internet infrastructure where these fiber rolls were carried by a set of 8 people on their backs, which of course also shows how much interested and how much eagerness is there for these people to help to build these kind of small networks so they can get online and use the benefits of the internet. Coming back to the details of fiber deployment, it's an 8.3 kilometer fiber optic cable. We have a contract with the local internet service provider called Everest Link, who helped us to lay down this fiber optic cable in collaboration with the local residents. We have now connected the school, hospital, and the clubs with this fiber optic connectivity. And this network will now run on a non-profit basis in collaboration with the Everest Link. So we are not offering this connectivity for free. We are charging a minimum fee, which will sustain the operations of this network. The rest of the so this is that photo where you can see the school kids using the internet. We still have some work to be done, which is more of the digital transformation, where we are still looking for some funds so we can deploy some applications and services on top of this infrastructure, which will include a Sherpa homestay service, innovation lab, a telehealth clinic, uh, STEM education, and another important thing is the security system, because these people migrate down to Kathmandu during winters, and for 3 months there is no one who takes care of their assets, their land, their homes, and that is the only thing that actually they have in their life. So we are trying to build an IP based system, so while sitting in Kathmandu they can still look after their property and their assets back in Kunde and Kumjung. Next slide. Why internet society? Well, I know people from IETF pretty much know about internet society, but we are a global non-profit organization dedicated to an open, secure, trustworthy internet for everyone, everywhere. We have more than 30 years of experience of championing the internet, and these are some of the networks that we do deploy around the world. Please, if you have a chance to talk with someone, please do share about these complementary access solutions called community networks, which can help us to connect the unconnected and bridge the digital divide that exists in today's world. Thank you so much. Back to you, Jane.
Thank you, Naveed, and you're right on time. We've got about 5 more minutes for any questions for Naveed or any remaining questions that folks had for some of our other speakers. Anyone in the queue? I don't see anyone in the room. Thank you, Naveed. That was excellent. Naveed's email is on the presentation, as are the emails, I believe, of some of the folks at the Internet Society who are involved in that community network project. Naveed, one question for you. Are you thinking of putting in a mesh network up there as well, just for redundancy?
We already have actually that mesh network that exists from the last year work, Jane. So we are going to keep that alive as well for the redundancy purpose. We are also thinking to make a model network, which would be this Everest Community Network, and then see if we can help the more larger Sherpa communities, because there are thousands of them who are having the same challenges as the people in Kunde and Kumjung villages.
Excellent. And one last question. Are you getting any free backhaul from some of the other operators, or how are you backhauling your traffic to the broader interwebs?
So we did get some discount from the local internet service provider in terms of the backhaul. You will be surprised to know, Jane, that a country like Nepal, which is complete landlocked, that's another problem that landlocked countries feel. The bandwidth cost is around $4 per MB. And when I got to know about this, I was like, okay. And I was calculating how much bandwidth I have in my Dubai apartment, which is around 250 megabit per second, and I pay around $70 per month. I was like really amazed. So we did get some discount, but still the cost of the backhaul is quite high, and that is understandable given the terrain and the problem that Nepal has as a landlocked country.
Yeah. We do have a Francois Nien who would like to speak. So he has a question for you. If we could keep it to a minute for the question, a minute for the response, so that we can skedaddle and get the room ready for whoever's next. Okay. Francois, you're up.
Yes, my name is Francois Nguyen. I was wondering whether Starlink works in Nepal.
Starlink is about to start. Starlink is about to start its operations in Nepal. They have not confirmed it, but then for Starlink, at least the latest deployment in Kenya, what I see is that they are charging $150 just for their terminal equipment, and then on top of that, you have to pay for the bandwidth charges. So I think Starlink might need some time to reach to these kind of people where the affordability still remains a big challenge. But yes, Starlink is coming soon to Nepal.
Thank you.
Thank you. And we have one more person up. Matt, 1 minute or 30 seconds for your question, and Naveed, same for your response. Thanks.
I have a really quick question for Innocent. I couldn't find his email address in the committee materials.
Innocent, are you still on the line? Thank you, Naveed, very much for your presentation. Round of applause. Innocent, are you still on the line? It looks like.
Can you hear me?
Yep. We can.
Hello.
Innocent, can you type your email in the chat so that Matt Mathis, who used to work for Google, can contact you? Great. And again, Naveed, thank you so much for your presentation, and everyone else. I think we're at time here. Curtis, any last words of wisdom?
Nope. Thanks everybody for coming out, and see you all in a few months.
And stay tuned. Curtis and I are rebooting the Gaia chat on the Gaia mailing list. And Curtis, you're on sabbatical this semester, yeah, but you're still doing a lot of work.
Yeah, it's hard. What does sabbatical mean when one has mono?
Exactly. And also children and everything else in life.
I will be shooting out an email to the list. People should make sure they get on the list if they are not on the Gaia mailing list, to talk about this remote peering discussion that went on during chat. I think that's a really
Yeah.
good thing to follow on. There's just a bunch of mystery as to why this even exists. And I've asked a few network providers and I have not gotten an answer. So maybe the list can answer.
I love that. Okay, first up on the list, remote peering, and then prep some of Barath's questions and backhaul with Naveed and company. All right, thanks everyone for coming out. We appreciate you, and thanks for staying with us for the entire time. And a round of applause for everybody and their presentations. All right, have a good rest of the IETF 117, and thank you very much to our presenters. We appreciate your flexibility.